Alright, in this video, I'm going to talk about two problems that are in your homework for my math lab in section 3.2, where you're dealing with multiplicities and zeros, multiplicities of zeros. And here's one of them. You want to find the zeros of the given polynomial function and give the multiplicity for each zero. Then you're going to state whether the graph crosses the x-axis or touches the x-axis and turns around at each zero. In this function, you got f of x equal to x cubed minus 14x squared plus 49x. So if I want to find the zeros of this function, I need to set the function f of x to be equal to 0. And that would mean that x cubed minus 14x squared plus 9x equals 0. Now the left side, I have to factor that out completely. So each term in this on the left side has a common factor of x. So I can factor out the x, and it has to be x to the first power because I have to take the one that has the smallest exponent. So to get what's on the inside, I'll divide each term by that common factor of x. So here x cubed divided by x will be x squared minus 14x squared divided by x will be 14x, and this should be 49x, by the way. Because it's up here. X divided by x will just be plus 49. And that's equal to 0. So I have x times x squared plus 14x minus 14x plus 49 is equal to 0. Now I can factor x squared minus 14x plus 49 into two binomials here. So I bring this x down. Let's see what we got here. X squared breaks up as x and x. Factors of 49 that gives me minus 14x will have to be 7 and 7. Now since the middle term is a minus, and the last term is a plus, the 7's have to be minuses here. So I have x times x minus 7 times x minus 7 equal to 0. But here x minus 7 is used as a factor twice, so I can write this as x times and then x minus 7 quantity squared equal to 0. And then from here I can go ahead and set each factor equal to 0. So I can set this x to be equal to 0. And I can set x minus 7 quantity squared to be equal to 0. Well, x equals 0 is already solved for x. For the x minus 7, quantity squared is equal to 0. The opposite of squaring something would be to take the square root on both sides of this equation. So the square root of x minus 7, quantity squared, ends up being x minus 7. Square root of 0 is 0. So x minus 7 equals 0. Add 7, you'll get x is equal to 7. So my zeros for this polynomial function will be, in this case, x equals 0 and x equals 7. Those are the zeros for the polynomial function. Now, what I need to do here is state their multiplicities. Okay. Starting with x equals 0. Well, x equals 0 came from the x, and the exponent for the x is the understood 1. So that means x equals 0 has a multiplicity of 1. And then for x equals 7, that's here, that x equals 7 came from the x minus 7 up here. The exponent for x minus 7 is 2. So that means x equals 7 has a multiplicity of 2. Now I need to state whether the graph crosses the x-axis or touches the x-axis and turns around at each of those zeros. And here at x equals 0, it has a multiplicity of 1. If we have an odd multiplicity as we have here, which is 1 in this case, and this 1 is an odd number, so that means it has odd multiplicities. So when that happens, that means that the graph of this function f of x crosses the x-axis. So that means at x equals 0, the graph of the function crosses the x-axis at 0. Now for x equals 7, it has a multiplicity of 2. And here we have an even multiplicity. So with an even multiplicity, the graph of that function will be touching the x-axis and it will turn around at that 0. So at x equals 7, we can say that the function f of x touches the x-axis and turns around. Okay, so that's how you'll work that problem out. Here you'll be given something like this. You have to factor this out completely, and then you can find out what your zeros are and state the multiplicities and determine whether the graph crosses the x-axis or touches and turns around at each 0 for that function. Here's another example just like that. Here we got f of x equal x cubed plus 7x squared minus 9x minus 63. We need to factor this out completely, find out zeros of this given polynomial function. So that means we need to let f of x equal to 0. And f of x is that x cubed plus 7x squared minus 9x minus 63. And that's equal to 0. So in this case here, we need to factor this by grouping. Since I have 4 terms, I need to group the first 2 terms, which is x cubed plus 7x squared, and group the last 2, minus 9x minus 63. And each of those groupings, I'm going to find a common factor. So for x cubed plus 7x squared, its common factor in that grouping would be x squared. X is in both of them, so I have to take the one with the smallest exponent. So x squared can be factored out. So to get what's on the inside, I have to do x cubed divided by x squared, that's x, plus 7x squared divided by x squared will be just plus 7. Now for the minus 9x minus 63, that's the other grouping. Its common factor will be a minus 9 because I know 63 is divisible by 9. So I can factor out the minus 9 because of the minus sign in front. So minus 9x divided by minus 9 would just be x. Minus 63 divided by minus 9 would be a plus 7. And you can always check by just distributing the x squared over the x plus 7 and also distribute the minus 9 over the x plus 7. You should get this back. All right, so it's obvious that the common factor here is x plus 7. So if I factor that out, the other factor has to be that x squared minus 9. And that's equal to 0. Well, x squared minus 9 is a difference of 2 perfect squares. So if I bring this x plus 7 down, and I can factor x squared minus 9 as this. The x squared breaks up as x and x. 9 is a perfect square because 3 times 3 is 9. And since it's a difference of perfect squares, One has to be plus, the other one has to be minus. So factor completely, I have x plus 7 times x plus 3 times x minus 3 is equal to 0. Now I'm going to set each binomial factor equal to 0 and solve for x. So here I'm going to have x plus 7 equal to 0. Then x plus 3 is equal to 0. X minus 3 equal to 0. And each one of those I'm going to solve for x. So for the x plus 7 equal to 0, that means x is equal to negative 7. And then for the x plus 3 equal to 0, that means x is equal to negative 3. And then for the x minus 3 equals 0, that means x is equal to 3. So these are my zeros for this polynomial function. X equal negative 7, x equal negative 3, and x is equal to 3. Now let's find out their multiplicities and the behavior at each of those zeros, starting with x equal negative 7. Well, the x equal negative 7 came from the x plus 7 up here, or up right here. That exponent is the understood 1, so x equal negative 7 has a multiplicity of 1. And now for x equal negative 3, well, x equal negative 3 came from the x plus 3. The exponent for the x plus 3 is also the understood 1. So x equals negative 3 has a multiplicity of 1 as well. And now for the x equals 3. Well, x equals 3 came from that x minus 3. Exponent for that would also be the 1. So x equals 3 will also have a multiplicity of 1. Now let's see if they cross the x-axis or touch the x-axis and turns around at each of those zeros. Well, by looking at this, each one of those zeros has a multiplicity of 1, and 1 is an odd number, so that means x equals negative 7 has odd multiplicity, x equals negative 3 also has odd multiplicity, and x equals positive 3 also has odd multiplicity. So we can say for each one of these zeros, the graph of the function f of x, starting with x equal negative 7, it crosses the x-axis, or the graph of the function crosses the x-axis. At x equal negative 3, the graph of that function also crosses the x-axis. And at x equal positive 3, the graph of that function crosses the x-axis as well. Okay. So hopefully this will assist you with doing the homework problems in my math lab. But do reach out to me if you have any questions regarding those problems.